Hey everyone. So a few people were saying that they were a bit confused by some of the questions from today's homework. So what I'm going to do is I'm gonna come up with a couple of examples here that we can kind of go through. So let's take a look at the first one. So given that the cosecant of pi over 4 equals the square root of 2, show that the secant of 3 pi over 4 equals the negative square root of 2. Okay, so we know that the cosecant of pi over 4 equals the square root of 2. Here's the first thing we're going to do, right? What we need to do is we need to notice something. And specifically, what we're going to notice is that if we take pi over 2 and add pi over 4 to that, then we get, well, that's going to be 2 pi over 4 plus pi over 4, which equals 3 pi over 4. Now, why do we care? That's the first thing we should notice. Like, why do we even care that pi over 2 plus pi over 4 equals 3 pi over 4? Well, what I want you guys to remember is that with all of the cofunction identities and all the other identities that we kind of talked about, they all have something to do with pi over 4. Sorry, pi over 2 rather. And that means that we are going to want to come up with some kind of relationship between the angles that we have in our question, specifically pi over 4 and 3 pi over 4, and pi over 2. We want to come up with some kind of relationship between them. And by doing what we just did here, we notice that the relationship is that if we add pi over 4 to pi over 2, we get 3 pi over 4. So that's the relationship between the three angles. Okay, and that's going to help us. Okay. So that means that if we want to check for the secant of 3 pi over 4, right, we're gonna see what we get here. Because again, we want to show that the secant of 3 pi over 4 equals the negative square root of 2. So the secant of 3 pi over 4, well, since 3 pi over 4 is the same angle as pi over 2 plus pi over 4, right, like we just showed, right, that means that secant of 3 pi over 4 should be the same as the secant of pi over 4 plus pi over 2. Okay, so the secant of 3 pi over 4 has to be the same as the secant of pi over 4 plus pi over 2 because 3 pi over 4 is the same angle as pi over 2 plus pi over 4. Okay, so now what we need to do is we need to remember that this looks a whole lot like one of our identities, right? Specifically, we know that the secant of x plus pi over 2 is equal to the negative cosecant of x. So that was one of our identities that we found out. And notice that this looks a whole lot like what we just came up with, right? Secant of pi over 4 plus pi over 2, right? Well, our identity is secant of x plus pi over 2. All right, so what does that mean? Well, that means that our x in this case is pi over 4. And that means that this should simplify to the negative cosecant of pi over 4. And from our question, we know that the cosecant of pi over 4 is the square root of 2, which means that we end up getting the negative square root of 2. So that means that we've shown that by starting with the secant of 3 pi over 4, we get the negative square root of 2. So we've successfully shown that secant of 3 pi over 4 equals the negative square root of 2. So therefore, yeah, secant of 3 pi over 4 equals negative square root of 2. Okay, so this is one example. I do want to show another example of the kind of question you might get in your homework. So let's take a look. So given that the cotangent of 13 pi over 14 is equal to the negative tangent of z, first express 13 pi over 14 as a sum of pi over 2 and an angle, then apply a trig identity to determine z. Okay, so this gives us kind of a step-by-step process, actually. It says first express 13 pi over 14 as a sum of pi over 2 and an angle. Okay, well, if we're expressing it as the sum of pi over 2 and an angle, that means that 13 pi over 14 should be equal to some angle x plus pi over 2. Well, we don't know what x is, so why don't we find out what x is, right? We can rearrange to solve for x. So that means that 13 pi over 14 minus pi over 2 equals x. Coming up with a common denominator, we get 13 pi over 14 equals, minus 7 pi over 14 equals x. Once we simplify, we end up getting that the angle that we were looking for before, that x, is 3 pi over 7. Okay, so that means that 13 pi over 14 can be expressed as 3 pi over 7 plus pi over 2. All right, well, how does that help us? Well, we know that the cotangent of 13 pi over 14 is equal to the negative tangent of z. That's a given in the question, so we can write that down. We know this. We also know that 13 pi over 14 can be expressed as 3 pi over 7 plus pi over 2. So that means that I can actually rewrite this expression as being, instead of cotangent of 13 pi over 14, I can write it as cotangent of 3 pi over 7 plus pi over 2. And that should be equal to negative tangent of negative tangent of z. All right, well, this is actually going to look a lot like one of our identities. Specifically, we know that the cotangent of x plus pi over 2 equals the negative tangent of x. That's one of the identities that we came up with. Okay, well, take a look. These look a whole lot similar, right? They look very close to one another. Specifically, where we have x in the identity, well, that's where the z is in our expression here, or in our equation. And where we have x on the left side of our identity, well, that's 3 pi over 7. Well, this means that 3 pi over 7 should be equal to z. So we can conclude that z equals 3 pi over 7. Okay, guys? So this has just been a couple of examples of how to go through these kinds of problems. Right? I hope it helps to kind of think through the process for these sorts of questions, even though I know they will be a little bit different. There are going to be kind of variations of them, but this is sort of the process that I expect you guys to follow. Okay, so yeah, I hope it helps. Take care, everyone.